Hello, and welcome back to Quantitative Reasoning Online. Today we'll be doing the Part 9B preview assignment, the two parts tutorial within questions. So let's start it. Appreciating depreciation. Sounds exciting. Let's put the window. Come on. All right, here we go. So let's see, 9B. We will create proportions from the sides of similar triangles. Whoa, some geometry here. From a missing side, when enough information about two similar triangles, find a missing side when we have enough information. Use mathematical symbols effectively. Determine slope when given 2 points. Determine the new point when given a point and a slope. Well, that's fun. Write the equation of a line given a slope and intercept. I'll show you a backdoor dirty method for doing that. Yeah, throw them out. Be about 20 minutes here. So let's proceed. Lesson 9, Part B. In the next class, you will use some geometry to determine vehicle prices. The tutorial for the preview of Lesson 9, Part D, appreciation begins here. That should be Part B. Okay. Two triangles are said to be similar if they have the same shape but not necessarily the same size. Okay. Now, if they have the same shape, it means the angles are the same. Okay. They have to be similar. They have the same general shape. You have different length of sides, but the angles are the same. The angles fixes the geometry. So we can say here is triangle ABC is similar to triangle ABC. So that just means the sides are proportional and the angles are the same. Like it says down here. And for congruency means the same. So if two triangles are similar, it means they're corresponding sides. Corresponding sides mean the vertical sides are similar. I don't want to do that. Basically, like, well, AB that's a corresponding side. They're both sides opposite the angle that's described by big C and little c. These two sides are similar or proportional. Those sides are proportional because they're opposite the same angle, be it 90 degrees, 80 degrees, whatever. And if they're corresponding and some similar triangle, they're also proportional to each other, which means the ratio of these two sides, which is 6/3, should have done that in red, will be proportional. We have the same ratio as these two guys, 4/2. And let's see, 6/3 is 2, and 4/2 equals 2. And I was looking at basically comparing triangle ABC to triangle ABC. corresponding sidewise. We can also look at the I need a color here. Yeah, I can compare the ratio of the respective sides across a triangle. The 604 equals 3 over 2? Yeah, because 604 would reduce to 3 over 2. So they're also the same proportions. Although I'll be honest with you, personally, I lean towards comparing corresponding sides across triangles. So now, if by chance I would have known what this length is, I'm just going to call it x. Okay, what that length is, because to get from here to here is basically halving. 6 divided by 2 is 3 is half of 6. 2 is half of 4. One would expect that this one would be whatever x is divided by 2 to be proportionally correct. All right, next. Enough. Holy mackerel. Here we go. Can't move it. Two triangles are similar. All right. The two triangles are similar. Good to know. So let's see. We have we're totally similar, which means these angles are the same, are congruent. 3. All right. And so the side's proportional. Now, when I look at these two guys, I look at the proportionality constant between triangles. I'm going to compare basically this value with that value. So the ratio between two triangles would be 30 over 10, or basically a factor of 3. So if I take 10 multiplied by 3, that's where I got 30 from. So that means x here being corresponding side should be 3 times bigger than the 8. And the y, which corresponds to the 6, should be 3 times bigger than the 6. So I'm looking at a 30, 8 times 3, and a 6 times 3 triangle. 18, 24, 30-inch triangle. Okay. So part A. I'm sorry, I couldn't somehow. Nope, doesn't stay. Doesn't say. So solve for the value of x using either of the proportions below. So, like I said, this is the one I went with. I tend to go with, basically, I like using triangle, compare the sides across the triangle. So we're looking at the corresponding sides. And if I do that, let's see, to get x, multiply both sides by 8. Of course, that's 8 times 3, or 24. Hint. Yeah. 24. Okay, they went by cross products. What was that? The cross products, you're just multiplying across diagonals. So 10 times x, 8 times 30, and lastly divide through to get x equals 24 inches. Okay. Part B, they're going to find how to solve for y. So what was y again? So let's do 30 over 10, y over 6. So 30 over 10, y over 6, these corresponding sides, and we'll do the third method, do cross products. So 10y equals 30 times 6, which is 180, divided by 10, we get y equals 18 inches. Yep, 18. Which we also solved on the triangle, which went away. Okay. Okay. What we have here, intro to question 2. Two friends sold the vehicles recently. Both vehicles were Dodge Durangos in very good condition and with similar accessories and normal mileage. One was 2 years old and sold for $26,000. Okay, here's the 2-year-old one. And the other was 9 years old and sold for $8,350. Graph shows 2 points representing data from the Durango information. Horizontal axis represents the time since the original purchase of each vehicle, and denoted by variable t. Vertical axis represents selling price, denoted by variable p. Okay, so time, sale price. The 2 points are named with the same variable d for Durango. D2 represents 2 years old and 9 represents 9 years old. Make a sketch of the graph, or right-click on the graph and open the image in New Tab so that you can print it. Okay, so I'm going to make a quick sketch of the graph. $26,000, 9, and $8,350. All right, next. And get to it again. So the coordinate of point D2 can be written as T2P2 and T2P2, and not RDD2. Okay. So that means this can be written as coordinate pairs. T first. So when T is 2, P is 26,000. This one's saying is when T is 9, P or Y will be 8,350. Okay. Okay, just one of them. Okay, so here we go. Yep. Remember, it's always going to, basically it's going to be the X and Y as your coordinate pairs. Except for us, X is time and Y is price. X, Y. Okay, what are the exact values of the coordinates of the point D9? Okay, well, D9 I already had it earlier. So when the x-axis, or t is 9, the price, or p or y, would be 8,350. There we go. Again, there's my x, which is time. This is y, which is p. It's always going to be the x, y in order of a order pair. And with the nomenclature we're using, that would be time and price, zero price. Imagine there was a line through the 2 points, and you determine the slope of the line between the 2 points. Refer to the resource slope if needed. All right. So let's draw ourselves a straight line here. Let's try and get on the points. Pretty close. Close enough for government work. All right. So slope is basically how fast is the line changing. How fast does the line change? And with a straight line, I'm basically looking for how is y changing with respect to x. And remember, this is basically I'm going to use some nomenclature, and I better use the same thing that they have. So this would be T2, P2, T9, P9. So what's my change in y? Well, it's going to be, we typically go left or right. So in how we do slope, so I got to take basically the rightmost value. Oops, wrong one. P9 minus P2. And my delta y, delta x, excuse me, well, I'm doing P9 first. I better do the same corresponding x value minus T2. Now, Bob, could I have done the other way? Yes. You could have done y value P2 minus P9. So now I got a bigger value minus a small value. But just remember, you got to keep the x's and y's together. The trick here the first one is 9 over 9, 2 over 2, and the second one is 2 over 2, then 9 over 9. So we're going to look for differences in how y changes over from point to point and how the x changes from point to point. Okay, so let's figure it out. So my slope, which is going to be delta y over delta x, and I'm going to use this guy. So P2, I don't know what P2 was. P2 was 26,000. P9 was 8,350. And then T2 would be 2 minus 9. So let's do our calculator here. So 26,000 minus 8350 is 17,650 over minus 7. Or minus 2,521.43 dollars per year. Remember, also got to keep that in mind. Y is sales. The X is the time is years. So it'll be minus. So for every year, not enough room here. Every year it'll depreciate $2,520.43 by my analysis. Okay. Notice the slope is minus because as I go left to right, the line is going down. So this here is indicative of a negative slope. So something you should also keep in mind when you're doing your math is have an expectation based on the graph. Hey, my line's going down as I go left to right. That's the ball's going to roll downhill. So I better have a negative for my slope then. Okay, a lot of talking. 2 points fine and there's to the 100th place if necessary. Let's see, how well do we do? Minus 2,025, 21, 43. Hey, we're right on. Right on it. So change in price. What we had here over years, yeah. Answer 25, 21, 43. And all we do is basically look at 2 points and in the numerator and denominator subtracted one from the other. In this case we subtracted 9 from 2, but we could have subtracted 2 from 9 and got the same answer. Let's see that. Let's try doing it the other way. So here, let's use this guy, P9 minus P2. So P9 was 8,350. P2 was, what was that again, 26,000? Yeah. 26,000 over T9 minus T2. The difference here now is now I have a so minus now a plus 7, but instead of a plus 17,650, I get negative 650 over here. So by switching the points, all you do is switch where the negative sign is. It is negative. And I still get minus $2,521.43 per year. That's why it doesn't matter which one you do first. The important thing is whoever you're going to do first, if you do for the Y, you got to do the corresponding X first in the denominator. Busy page. Okay, the information about Duran could also be presented in a table for the next 5 questions. Use the information you found in question 2 to complete the table. All right. So in question 2, the previous one means y equals, well, actually, hang up that a second. What they're having us do is, slope was what? Minus, if I kept that number up there, minus $2,521.43 per year. All right. So from the points, where's the graph at? So as I move away from here, every year, for every year I go over, I'm going to go down 2,521.43. Or if I go back, I'll go up 2,521.43 and so forth. Shoots, I lost that. Double check that number. 252143, yes. Okay. So I'm gonna need this guy. So I'm going up in years. So let's add 2143 there. So let's clear this out. So 26,000 plus 2521.43 means D should be 28,021.43. And let's go from D to E another 2521.43 plus 2521.43 for 31,042.86. Now I'm going up, increasing age. Let's subtract from that point. So 26,000. Now it's a year older. Now being a year older, it's going to decrease in value. By how much? By the slope. 2521.43. That's not what I wanted. So he should now, a year later, he should be only worth 23,478.57, and so forth. Do another subtraction. Minus 2521.43. 20,957.14. And subtract again. Year older, another year less value. For 18,435.71. And let's just do it. Let's do another one. Okay, and one more. And one more. Dang that one. Oh yeah, subtract. Okay. And lastly, let's see what we get after 9 of these guys. I better be pretty close to that guy. 83.49.99. So, okay, we're 1 penny off. That's because of the rounding error, the rounding we did earlier. All right, it worked. Aha, huzzah. So let's see what they say. Say what? Okay, So 26,000 minus is 23,478.57. Did I overdo this problem? I think I did. Okay. 23,4. Oh, okay, next 5 questions. All right, so that's question 1. Do you want, yes, I do. Keep going. Find an estimated resale price for 4-year-old Durango. All right, 4-year-old Durango was, here we go. Here's a 4-year-old Durango. 20,957.14. 714. Got it. Estimated resale for a 5-year-old Durango. 5-year would be C. 18,435.71. 18,435.71. Value for a 1-year-old Durango. There you go. Estimate was 28,521.43. 28,521.43. Brand new Durango. Estimate was 31,42.86. Okay, one multiplication, I just kept on adding. 31,42.86. All right. Okay, now use the information in the table as well as other information to write an equation for it. All right, so calculated price is going to be something times time. Okay. That's going to be your slope, which we have as minus 2521.43. And this is basically going to be value at time equals 0, or what we call the y-intercept. And we have that. We have M. M was on what? Minus 2521.43t. And then basically the value for at E, this guy, 31,42.86. Okay, y-intercept, I said that already. So here P is, that's what we got. That's what we came up with. The y-intercept price when time t equals 0. I have no idea what they just did there. It's not like they repeated themselves twice. Such the case. All right. So like I said, we took the table, used some other information we had. Slope. The slope as a factor of time has to be added, subtracted from something initially, and that would be when t equals 0. And such and such. Slightly confused. All right. Clearing. So, can you do a triangle and do proportions? I'm pretty confident. Can you find missing sides of a triangle? Known proportions. Symbols effectively, yeah, that's basically the congruency, and I always got to review those things myself. Slope given 2 points, oh yeah. Given a point and slope, find new points, oh yeah. And find the equation of a line, oh yeah. In fact, I'm gonna, where's the back button on this guy? Okay. We did a lot of stuff here. We call it, well, we know what the answer is. another way to have done this, we still would have found, if given these 2 points, I could have also have used another formula method to, how long is it going so far? Another formula method to find it. Still got to find m, the slope. You're going to be, the 26,000 minus 8,350. Okay, 2 corresponds to 26,000, and 9 corresponds to that guy, which again will give us minus 20. What was that number? 25, 21, 43. All right. Now, assuming straight line, we know right away it's going to look like something like mx plus b being the y-intercept. We know the slope. Okay, we know the slope. Okay. Oops. I'm going to go to the p equals t plus b. All right. We know a point. Okay. So basically, as t varies, it's going to subtract or add from this base, this y-intercept of b, when t equals 0. We know a point already. I know when p is 26,000, at t equals 2, and plug those values in, that makes that equation from a 3 variables based on just one unknown variable, b. So let's just finish up the math here. So let's multiply this guy out. Times 2. So that's 26,000 equals minus 5042.86 plus b. Solve for b by adding this to both sides. You guys cancel. So plus 26,000. So that's going to be 31,042.86 is B. So put the fact that we just calculated this value into here. Now it gives us that P equals minus 2521 43T plus 31,042.86. The same answer we got here. 25, 20, 43, 31, 42, 86. So we got the same answer without having to go through all that table. Just use knowledge of how a straight line equation works. Y is mx plus b. We got the m from the from the two known points. Then we plug one of those points in and solve for the missing b. Because this b is going to fit the line that passes through those points. Okay, enough rambling. So with that, the tutorial is done, and I look forward to seeing you shortly in the question section of 9B.